the relation between concrete steel reinforcement, the bonding. So while we can put together concrete steel, it's two different things. How can we put together to resist or to bear the load? So in this case, the varies. So first, the basic concept for the reinforced concrete structure. Actually, we have talked this about last class. The reinforced concrete structure is a non-homogeneous material with a high compressive strength and very low tensile strength concrete. Because we see concrete is made by water, sand, stone, cement, and some proportion mixed together, they get this concrete. And this remember who invented this thing? Concrete. Yeah, the French guy. It's ammonia. It's ammonia. A French gardener. Yes. So it's I remember it's in 1949. Oh, 1849. The concrete, this material, actually, the most important thing is non-homogeneous. It's compared with the steel or other things we have learned in the material mechanics, other material. This material is not homogeneous one. So that means for this material, it's very hard to get theory formulation to calculation. So most of this, the formulation used for concrete or reinforced concrete is come from experiment. A lot of experiment, because of lots of data, and then you fit this data across some formula. So that means some of the formula have that I would say it's a limit scope where you can use this, or some situation maybe you cannot use it. So, and another characteristic is high compressive strength and low tensile strength. It's like the masonry material, stone or bricks, like this. And still, kind of material with very high tension and compressive. So here, not only tension, but also compressive strength. Still, the strength is both of these tension and compression is very high. I mean, so the compressive strength of steel is high, but if you use this characteristic, then this means it's not economic. Because if you use stone, some concrete, also you can go to very high compressive. So steel mainly used for the situation where we need a high tensile strength. So that means, for example, we've got a beam. In this beam, where should we put the main steel bar?
Inside the beam.
Upper. Here or here?
Down.
It's down. Yeah, so that means normally in this the main steel is put here used to resist the tensile force. So this upper part just the concrete sometimes. Yes, some situation like this continues to bridge. Here we see it's a negative moment. Then at this position, we should put some steel to resist the tensile. But depending on wait at the position, what type of force, what type of movement, or this force, what type of force is it you need to resist, or you need to bear? It's tensile or compress? Here is a at the low part is a tensile, but this up part is a compress. But here, on the contrary, as the upper part actually is in tension, it's different. The bearing port and the middle port is different. So not only when we see at the low part of the beam, we should put more the steel bar. Maybe at this division, we need to put more on the top, on the upper part. So usually, according to the real situation, to see what type of force is at this position and what we need to do the design according to the real distribution of the moment of the force. To be able to bear the tensile stress as the steel, actually this is the basic characteristic of the concrete steel. So actually, just now we have already said excluding pressure, but the pulling tensile, steel bar bearing tensile. This will be able to use the strength fully and produce a reinforced concrete structure. Actually, this sentence is not very correct. Yeah, we use the compressive strength, the concrete, and tensile strength of steel to build the reinforced concrete structure. Yeah, but the reason why they can work together, why these two things can work together?
Because they have good bond.
The bonding. Bonding is one of the main reasons. Actually, only bonding is not enough. Supposing if you
resistance.
Plasticity also.
Like we see a little bit after we introduce this. Actually, yes, the bonding is one of the most important thing in this world. Actually, still have another reason. Because these two material, you say if you, in the companies, if you not use steel bar, maybe if you use some plastic material, will they work well together?
No.
Why?
If you put it together, the aids can, because of the composition, chemical composition of the plastic. Our characteristic of the plastic.
And the cement type also used to make the concrete is different. So if you use the plastic material in the concrete, it will affect the function of it.
Okay. In some case, some people use some bamboo in concrete, just replace the steel bar. But it's not very strong. So one thing is the bamboo doesn't have the high tensile strength. Actually, another thing is thinking, what's another reason?
I'm breaking
The strength.
What?
Bamboo is not strength from
It's not steel. No. Actually, these two different materials under the influence of the temperature, we know no matter both the concrete, steel or bamboo or wood, those things on the high temperature they are expansion, and the low temperature they are contraction. concrete and bamboo or concrete maybe or plastics, there's a coefficient of the temperature is quite different. Once the temperature is changed, maybe too high or too low, there will generate relevant
Expansion.
yes. So they will move together, so they cannot bend it well. So one effect is the tensile strength is low, like the bamboo or plastic. Another actually is because they cannot bending very well under different situation, could be high temperature or low temperature. But for this steel and concrete, actually these two materials have similar coefficient to the temperature. So that means when the temperature is changed, there's a formation induced by the temperature actually similar. So that makes them a good bending effect. They can work together. So actually, this is another very important thing. So the reinforced concrete structure actually is made of concrete configured by the ordinary mechanical steel bar or the stacking of the reinforcement. So that's actually this means normally we know before in the reinforcement concrete, the steel bar is made in just like the let's say load. I check this word how to pronounce it. I need to put this. So actually, in the column or the beam, the steel reinforcement, the steel bar, we made different shapes. In the column, we use this type shape, and in the plate of the bridge, we just use the one surface, a plain surface mesh. And also in the beam, we see some beam like this. So you see, for this type of the smoke girder, the steel bar is made a certain shapes. So this circle line we call it the spiral, and also the mean steel actually is the longitudinal at the bottom. And all this then actually is used to compute the shape of the books and make it stable. Have you ever been to the construction site to see how they make this? No. So once maybe we had one chance to go find some technical to see. So see, do you know what's the meaning of this circle? function.
That means every materials for that means cannot move this
Not
arm.
move.
Yeah.
Actually, is no. The main function actually is yes. Some cases we can location is fix the location of the steel. Actually, the main function is this circle floor. See, we fix on the steel bar, and actually half of this to the move the yeah. So this distance make sure the steel bar is covered by the concrete have enough thickness. Because if the color thickness is too thin or the size is too small, that means the steel bar is easy to be corrosible if affected by the wet weather or another, maybe the yeah. Actually, that means we got enough thickness to protect the steel bar.
Protect the distance.
Yeah. So the meaning of this block.
I've not heard
Hmm?
the name of that circle.
The name of this. I check the English name. I forget the English name. It's like this. Right? No? Closure block. See is this. Hey. Sometimes we use this. Hey. No, this. Blocks. Maybe not really. Focusing. Custom block. Custom. Yeah. Maybe yeah. Maybe you can use this. Actually, I'm still learning. Use this again. Cushion block. Cushion. How to pronounce it? Cushion block. Okay. But sometimes actually, not only this steel bar inside the beam. Actually, some case I check is it's like this. This steel.形容 this. Steel. So sometimes not only the steel bar is putting the concrete to make this reinforced concrete. Sometimes we use the just section steel. Some section like this type of steel or something like this. What's your call this type of material? Section steel. Okay. Sometimes in some grade they have some practical use. Not only use the steel bar, sometimes they use this type of steel section steel put into the concrete to make this beam. So that means this skeleton, yeah. But here, the textbook will give this sample to show the function of the steel bar. So here, in this beam is a plain concrete, no steel bar inside. And this beam, they put this steel bar inside. So this is the basic shape of the steel bar in the beam. The circle one, we say, is a stirrer. The main function is to fix the steel stable selective of the steel bar and also resist the shear force. And this red point is the mean longitudinal steel bar. It's along this longitudinal direction. Those steel bars are put here mainly to reduce the tensile force and resist the moment. But these two steel bars actually, we see the diameter is 10, this diameter is 16, so relatively smaller. So those two steel bars, in most cases, is used to fix the stable skeleton. You can imagine if there's no these two steel bars, this circle one cannot stand it. Yeah, so actually this tool is mainly put here because the structure requirement not from the design, not for the calculation of the force. It's just to make this stable skeleton. And the most important thing is this longitudinal steel and also the stirrer. In Chinese, the word is to complete. We call it the Wu stir type English. Remember, it's like this stir. Still, I'm checking this very long. Still or stir. Stir. Lost the line. Stir. Why there's no sound on this computer? Because the mouse is no sound.
Box collection is
What? This is open now. This one? Yeah, this box has no sound out. So it's very interesting. So this example to show what's the function of this steel in the concrete. See, the span is 4 meters, and the concrete load is placed at the middle of the span, and the beam section is 200 by 300 millimeter. This rectangular section is very simple things. And the grade of the concrete is the C20. Actually now, C20 is very weird. The the most smaller one is C25 now, and this is no, is very we in the real construction we don't use this because the strength is too low. And the detail is shown here. So the concentrated force in the middle span, and the force. See the different failure mood. From here you can see the plane concrete is just break down suddenly. Actually, the crack is so large. But if we put the steel bar inside, you see there generates a lot of small crack here, and the beam is bending gradually. Actually, it's not like this. Just see this straight line. This straight line means the crack is suddenly happening, suddenly break down. But this is the circle. This is circles. This is curve. This curve means that the beam is bending gradually. So generates such a crack. And at this point, you see the concrete is at last the beam destroyed. When the beam destroyed, that means the upper part of this concrete is crashed, and the beam here is a large concrete, and the steel bar is a brick. So at this situation, this beam destroyed. It's quite different with this. So we call this actually a brittle failure, and this is plastic or plastic failure. Actually, these two different failures. This, the first one happened suddenly, and no very, how say, you have no time to save it or to
renovate.
Yeah, to repair. And this you can have very how say, you have time to repair or yeah, that's the difference. So that means this situation is very dangerous. This situation you can do some math, you can use some method to repair or just save the structure. So this is some of the results of this test. For the concrete, for the plain concrete beam, actually, the load is only 8 kilonewton, and is controlled by the concrete tensile strength, dealing with the brittle fracture. So that means when the beam is destroyed, actually it's controlled by the tensile strength of the concrete. So we know that concrete has very low tensile strength. So that means this the plain concrete beam, they can only bear resist 8 kilonewton this load, and at this load, the beam is destroyed. But for this reinforced concrete beam, the ultimate load is 36. So that means nearly 12 times. So the steel is in tension reaching yearly. So you know the meaning yearly. What's the meaning yearly? The steel bar, if you pull the steel till when the force reaches some distance, the steel began to have a very large deformation. Before we have a large deformation, at the beginning of this deformation happened, at this stage the force, means the force is replaces the strength of the yielding strength. After that, break. After some of the deformation, it's the strength you can use a large strength to pull it because the strength of the steel bar is increased. At some stage, the deformation is large and the force is becoming large. And then after that, the steel will break. Actually, when it's broke, it's like this. Because the neck because this steel actually is a material, plastic material. It can have a very large deformation in it under the force. So the formula of this experiment is the combination of the steel and concrete improve the bearing capacity and the mechanical property of the structure. So why the combination of the steel and the concrete can improve the bearing capacity? Say the force improved nearly 5 times. For the plain concrete, it's determined by the concrete tensile strength. Once the load is over the concrete tensile strength, the beam will be destroyed. But for this, if we use the steel inside, it's controlled by the steel tension strength. Maybe sometimes it's not controlled by steel tension. The ideal situation is that the steel line reaches tensile strength, the upper part of the concrete reaches the compressive strength. This is the ideal situation. But sometimes, maybe this upper part, the concrete is reaching compressive strength and crash, but the steel have not reached the tensile strength. Or some situation, the steel reaches tensile strength, the concrete have not reached its compressive strength. So what type of situation will happen like this? Which reason? Which situation can happen like this? When the concrete and the steel bar reach the strength limit at the same time, or some situations, what type of situation the concrete have not reached the compressive strength, but the steel bar already reached the tensile strength? What do you think of the main reasons? What inflect this different film? What will be this reason?
The type
of what?
of the concrete.
Concrete.
Yeah.
The type of concrete, yes. Actually, it's not the main reason. You mean the different grade of concrete, say 40, 50, yes. Sometimes, that's a little. Can be one reason. Yeah, that's one reason. But from another aspect, from the steel reinforcements, steel bar, what is it? It means you put too much or too small steel bar inside. If you put too much steel inside, what will happen?
You have plastic
It's too much steel inside. So the concrete reaches the compressing already, but still have not reached steel strength because you have lost steel by inside. But if put too small steel already break, but the concrete have not yet. Yeah. So that means when you design the beam, have a limit, have the scope of the reasonable steel ratio, not too much or not too small. That's the very important thing in design. Some people may think, I don't know how to calculate it. Just put more steel inside. It's safe. Actually, more steel inside not really safe. Sometimes maybe make the structure is unsafety. So the reason for working together, the steel and the concrete. Good bonding, yes, just like the talk said, good bonding between the concrete and steel. Hence the two can be reliably combined into the integrate. And this deform well and load together to complete the structural function. So that's the first important reason, good bonding. And another one, as just now I said, the influence the temperature, the thermal expansion coefficient. Thermal expansion coefficient. For river, still by the 1.2. For the temperature for the concrete is 1.0 to 1.5. So actually these two materials have a very similar thermal expansion coefficient. Both have a similar temperature coefficient for the linear expansion, so there is not a great temperature stress and very little information and the destruction from strength because of the low temperature change. So that's another reason. They are very similar thermal expansion coefficients. And the sufficient cover thickness, just now we said, function is circle block. Sometimes it's not circle block. Sometimes you will see actually just use the rectangular block that's under the sliding of the cell bar. Put on the mood. So the different shape of the block just to make sure it has enough thickness to the concrete to practice the steel. So such the cover thickness crossing for the concrete can be difficult and so completely alkaline. So that means under this situation the steel will have good working condition. It's not easy to be crossed. Protect the reinforcement against the crossing. Corrosion. Sometimes I find my pronunciation is not very correct. So that's three aspects. The good bonding, the similar thermal expansion properties, and the substrate cover thickness. Make sure these components still are become good together. So the main advantage or disadvantage of the reinforcement concrete. The advantage, actually, this is very easy. Last class we have talked about this. The material is very easy to find because the sand, soil, water, cement, something like this. Actually, cement is also made from the soil. What makes cement? How to produce the cement?
But mineral.
Cement.
Mineral. We take it. We need rock.
Yeah. Sometimes rock, not all the rock. Actually, it's called let's say what's type of the rock? Limestone actually. Limestone by 断烧 is this?
Yeah.
How to pronounce this thing?
Calcination.
Calcination. Yeah. Limestone by this calcination we can get the same. Not only that, so we still need to more this brand to the power like this. So the most important advantage is this: use local source and save reinforcement concrete material. And another advantage is good durability and fire resistance. Compared with steel, they have got good fire. Actually, we know the disaster of the American or this the double top was to me double strong top. You know, you do know this.
Which just
From the top in American 20 tower,
Oh.
20 tower to is this to no. I check what's the name.
The Eiffel Tower.
From this one, you know,
yes, Doctor.
it's her
Gold.
affected by the or is the Bible. Actually, in this exchange, one of the most big reason is that because the steel inside is welded by the high temperature, and then just the tower collapsed. Twin Tower. It's not when this happened.
2001.
Which year? Remember?
2001.
2000. Oh, do you? Oh, yes. Do you remember wrong? Do you?
21st September.
19. Do you? Which year? 2000. Is it 2000? See, this word, this sentence, I just translate you see. So this sentence means this sentence say the temperature reach 1,100 degrees produced by the combustion because there's a loss of oil when the plane attack the building, loss of the oil is put on the building and then it's burning. The temperature is reached 1,100 degrees. Actually, when the temperature reaches 425 degrees, the steel begins to be soft. And when it reaches 650 degrees, they lost half the strength. So, one of the most biggest reason of the collapse of the building is because of the high temperature. So that means the steel actually have a very, compared with concrete, have a very low or poor fire resistance.
Yeah.
So the concrete actually have good durability and fire resistance. So if the building is built only by the concrete, actually it may not be complex. So maybe just the part hit by the clay will be destroyed. Other part will not be collapsed. But because they have lost the steel inside and burning by the oil, and the steel is soft and lost the strength, then the other part, because the building is so tall, the twin tower is so tall, actually the plane is just 100 small part of this, but at the end, the total building is collapsed. So the main rate calculated by the temperature, the fire. So in the building, actually, the fire resistance is a very important thing. We see how the concrete the check. We can reach 1,200 degrees. Actually, very high temperature. So another advantage is good modulability and easy implementation of the structure. Actually, this compared with the steel also have good modulability. Secretly, you can make different shapes. But for the concrete, this advantage is more. It's easy to do these different shapes because it's yes, and a good structure integrated for casting inside or prefabricated and enough stiffness. So that's some of the advantage of the concrete. So besides the advantage, there's a disadvantage. Actually, everything has a good aspect and a bad aspect. So for the concrete, the first is the heavy self-weight or high self-weight. So you know now, if you can invent some very large and high strength material to replace the concrete, maybe the span of the bridge or the height of the building maybe can increase greatly. So because for the large span bridge, actually I would say nearly 90% of the bearing capacity was used to resist the self-weight. The normal use, the car or the load, some of the other load is actually very limited part, maybe not more than 10% actually. So that's just like this. The biggest enemy actually is the self, just like human. The poor crack resistance. So it's easy to crack because they have very poor tensile strength. It's easily crack. So how to fill this problem? Use the pre-stressed concrete. Push the first. Make it not easy to crack. And the construction is influenced by the climate. As we said, when it's raining or the wind or the cold temperature or hot temperature, it all can be influenced by those things. Too hot, too cold, we have to stop construction. Because when the concrete was generated, you just before from the concrete generator mix the finished mixing of this soil and water to make this concrete. From this point to the concrete start to hardening, this time, how long will this time be? Have you ever think this? I mean, so after the mixing of the, I check how to sequence it. Maybe I'm not very clear. Say, mix, yeah, it's mix the concrete. So, yeah. So down was mix staging. So I mean, so from the concrete, from the moment fix the mixing, or no, just we pull the concrete into the model. From this moment, when will the concrete begin to hardening?
20 days.
20 minutes or
Maybe sometimes 20 days or maybe before or earlier than that.
yeah, that's depends on the mostly depends on the temperature.
Yeah.
Maybe normally it's 25 minutes. Yeah, that's depends on the temperature. If the weather is too hot, this distance will reduce. Maybe 20 or 10 minutes is start to. And another disadvantage is difficulty strengthening and restructuring, poor performance of the heating and noising. What's this mean? Difficulty strengthening and restructuring. So this means if the company was destroyed, it's very difficult to repair the poor performance, the heat and the noisy. So we normally see some people are working on upstairs. It's a very hard sound, especially in the night.
Yeah, the sound.
There's a lot of the conflict between the neighbors just come here. You working on here, maybe you find it sounding very small, but yes, it's very loud sound. So that means the concrete actually has a very poor noise performance. So the concrete, we have also made from cement, soil, sand, water. So it's here is a certain mix of the different grade. It's a non-homogeneous materials. Concrete quality is a high strength and workability, durability, economy, and so on. Those things we have already introduced. But here, manufacturing effect is strengthened, such as the cement grade. So, not only concrete, and cement, and different type of cement. Cement grade actually have a great influence on the strength of the concrete. And aggregate the properties. Aggregate properties, which means because we use different sand, soil, so the proportion of the size of the soil or sand, different aggregate also influence the strength of the concrete. Yeah. if you soon have to go to the laboratory on the construction site, you can see all the mixed staging. They have different sizes slowing. Not only one size slowing, it's a small one, large one, different sizes. They make this different proportion mixed together. And the concrete age, we normally know on the standard conditions, the concrete needs 28 days to reach the full strength. Normally, when you pour the concrete into the model, sometimes normally it's we need to 7 days. They have to remove the model. The computer can reach the 70 to 80% strength. And then you can just remove the model. Yeah. So the age, the concrete age, also very important influence on the strength. Production method. Actually, this lots of different methods to produce this concrete. Yeah, it's 1 hour concrete. Actually, 20 past 8.
You're supposed to go at 9:05. 9:05 to 9:50.
9:05 to 9:50. Okay. So it's pure condition. As a pure condition, we all know after we put the company into the mold, we need to how to say to cover it or use some water to make it wet, to make it good condition to dry it. So the curing condition, if you just put there and leave it here, maybe and at the end there is some crack and the strength is low. And also some of the test method, this will reduce a little bit because the for the computer actually have different methods to represent the strength and different test methods that you can get different right, different value. And the computer compressive strength depends on the lateral deformation constraint. Actually, this is I think belongs to here test method, different test method. The lateral deformation constraint. Actually, we have already said something about this. We said we put the concrete into the circular tube. This one the solution you see have the constraint around the concrete. So the strength is different. The lateral deformation constraint. If you constrain the lateral deformation, of course the concrete I think it's very easy to understand the strength will be improved. Another situation, if you pull at the lateral, if you pull outside, it gives the concrete some of the force, pull it. Then the concrete strength, I think you will get a very low value. So say now we come to here, the strength of concrete strength. They have different value. Cubic compressed strength, FCU, cubic. Normally, these three indicators. And the actual compressive strength, FC, and tensile strength, FT. So what's the name of these three different indicators? actually, this given this tool, this first tool, FC, is the value is different because of the sample, the test method is different. And the other one is the tensor strings. The first tool is the comparison strings. So the factor affecting concrete strings in these is physical performance of the materials, concrete mix, pure environment, construction method, shape and the size of the specimen. This point, for this cubic and actual compression, they use different shape and size of the specimen. Test method, the loading condition, and the loading model of the sample. So those indeed actually have the same influence to the cubic compression and actual compression. Only this, the shape and the size of the specimen. Actually, this is the mean influence of this different value. We see the cubic compression strength FCU. This is the basic strength index. So we see the C40, C50, something like this. That's this FCU. It's cubic compression strength. So this is the basic strength index. So when we do the experiment to measure the FCU, the test specimen, the side length of 150 millimeter cube specimen, we do this specimen to do the experiment. Standard cube method of the specimen is temperature 20 and this symbol. Plus or minus. Okay, plus or minus 3 degrees. Relative humidity was not less than 90% of the moist air during 28 days. That's the standard temperature, standard conditions, standard cure method for this specimen. And the standard test method test the lubricantly coated surface. What does this mean? So that's the cube. The cube the dimension is 105 millimeters cube. So we put this on the test bed. And this surface, the up and the lower surface here, it was lubricated. If you put some of the oil or some type of oil lubricated, that's oil make this total surface connected with the test bed tightly. If you don't put the oil or the lubricate, maybe in the middle, we connected with the bed tightly, and the edge maybe just have they connect not so tight. So finally, the force may be concentrated in the middle. So the result you have a different result. Yeah, the value is quite different. So the standard test method, so as the up and the low surface is lubricated coated. The whole cross section is in pressure, so that's the main purpose to lubricate it. The load speed is 0.15 or 0.25 megapascal per second. So that's the test method. So one question, so So right now, what's the mean load speed? If you test machine, you will add the load on the specimen. So how fast you add the force? So that means the increment is the speed is like something like this. So if we cannot suddenly put very hard load, so you add the load gradually on the specimen. So given the speed, given the load speed, you will get different results. So the factor affecting tube strength are size and the text method. So we see here, because of the FC, the size of the specimen actually is different. Here, cubic is used 150 millimeter cube. And here, actually, it's used the same, but the length actually is 300 millimeters. It's different size. So the compressive strength changed from the C25 to C18. So a long time ago, we have about the C50, C20, but now the lowest strength is C25. So just remember what's the influence of the strength of the concrete. Besides this test conditions, was not the influence, was not the factor will influence this. How to design the concrete to get the different strengths. To get the different strengths of C25, C50, or C16, how to get these different strengths, compressive strengths, use what method? How to design this?
We use like some curriculum or something.
No. Actually, first we have to think about different materials, so cement, sand, stone, water, or some another, let's say, what's the Chinese, what the Chinese means? This. What's wrong with this?
Maybe internet is disconnected.
Really? Maybe because
Flash is disconnected.
I think that's because of the university network. There's no network now. So let's try again. So sometimes we put some another, let's say, material, some of the high strength concrete, they put some fiber inside, or some,
I agree.
yeah. So to design different proportion of material, and also different material like the different stone, the size of stone or the material of stone. You see, even the stone have different stone have different strengths. And also maybe they put some iron fiber inside to improve the strength. So especially now, when the strength is larger than 50, normally we call high strength concrete. If the strength is lower than 50, that's the normal concrete. So now there's a research tradition to invent the high strength concrete. Now in some of the research they can make the concrete the strength is reach 120. So it's very high, very strong concrete. So that it's divided into 12 increment. The middle increment is a 5 meter. For lower than C50, it's named as ordinary strength concrete. For C50 and over above 50 high strength concrete. So now it's just named like this. So the cube compressive strength FCU, the basic strength in space. Actually, FC and FCU have the relation. So here it said it's worth to mention that the concrete ceiling the compressive strength. Oh no, this is not the compressive. So here we said actual compressive strength. Now here comes another cylinder compressive strength. Not the actual compressive. This is the cylinder. That means the specimen is a circle column. They use the circle column to test the.
So the this one is a different.
Oh no, this is different. So here, the first line is cubic compressive. This is the basic things. And another line is actual compressive strength. Actually, for the actual compressive strength, the specimen still is a rectangular shape, but it's long. It's not a cube. It's a 300 millimeters long, and the section is also 150 centimeter, and 30 meters long. But for this cylinder compression, actually, it's used in United States, Japan, or Europe compression with a diameter of 6 inches. So it's the specimen actually is a column. So it's not surprising. It's column and a height of 12 inches. So that's the different specimen because of different rise. So here is the cylinder compressive strength. And this cylinder strength, compressive strength, and the cube compressive strength have this relation. FC, how to pronounce this? FC prime. FC prime. Okay. Equal to 0.79 FCU. So that means this will call cylinder compressive strength is lower than the cube compressive strength. Because it's a column with 305 millimeters, so the specimen is very high. For the cube strength, it's only cube, 50 centimeters. So the different specimen got different results. So we see that second, the actual compressive strength. Actual compressive strength is able to reflect the meaning the compressive strength of the concrete structure, which is 50, 50, 30. So it's a present. It's not a column. So in Europe or America, you use column spacement. In China, we use the prism or cubic. So,
Joshua? Previous page. May I see the previous page? May I see?
what is that?
Yeah. Yes.
No, actually, I've already sent you this. You guys, have you got? Yes. Yeah. So,
Okay.
So for this actual compression space, the spaceman is different. 50, 50, 30 centimeter prism. And the standard value of the actual compression space and also have a relationship with the standard value of the cubic compression space is equal to 0.88 AFCK. Here we should pay attention. We got another symbol A. So the A has a different value actually for the normal strength concrete or the high strength concrete. So this value I find the value you can see here, I will put it here, it's a 0.76 for the normal strength. When you go to the booking and find it, because the value A have different value for the high strength concrete or the normal strength concrete. Let's make it pick up the book. Maybe.
Okay, so because you're waiting for the office to give us. Maybe next week.
Yeah, probably say ask office the will give you next week.
Yeah.
But next week we hold only time my class monthly. I went.
We have two classes.
What? Really? Next week is Monday, and Tuesday, Thursday is the holiday.
Oh.
Thursday holiday, and
138 holidays, right?
Thursday holiday, and next week here is actually this also holiday is event to 1, 2, 3, 4, 5, 7, 6 till I think till now.
How is now
National Day, national holiday.
October.
I mean next week we have only class at Monday.
Maybe this weekend we
29.
we have extra class. This Sunday.
This Sunday?
Sunday, yes.
No. This Sunday we do have class.
Yes, but it depends on the holiday. So that we want
No, actually, I remember we will have class maybe at the next Sunday.
Oh,
I think then you will receive the notice. The office will put you.
Maybe they do their
But we have eight days holiday for the national day. And not only national day, also the middle autumn, 中秋 in China, 中秋 in
We start from
Because
29.
yeah.
29.
last year, New Year happy day didn't enjoy the Chinese people. Maybe this vacation will be happy. This is
yes.
last year.
Yes, yeah.
Happy New Year's.
Yeah, we are coming.
Happy New Year.
We started coronavirus.
We are coming.
Okay, we finish this part. The actual compressor strength So also have this relationship with the cubic capacity. It's a 0.88 and plus A. A equal to 0.76 for the normal strength computer and equal to I write this when you go to the list, go to the book, you can see. So this FCK equal to 0.88 R FCUK and FP07 for the small C50 equal to 0.78 to 0.8. So that's given value. Hey, you can find out the textbook document. 0.76 when the strength is smaller than C50, and when the strength is higher than C50, so it means high strength concrete. This value is different according to the strength of the concrete. When the strength is higher, this value will be larger. So another index the tensile strength. So this former two is the compression strength. Another one is the FT, tensile strength. Concrete tensile strength is much smaller than the compression strength. It's only with 1/8 or 1/18 of this compression strength. Actual tensile strength is also a basic strength index. The mean test method is a face-to-face tension test method or splitting test method. There are two methods to test this value. So first one is a face-to-face tension method. So that means, so this specimen, the specimen is 15 centimeters long, and at the end we put the reinforcement inside, married inside 15 centimeters at this two ends, and leave 20 centimeter plain concrete, and then pour at these two sides. Specimen, the dimension is like this. The section is 100. I think this one is not 100. It's 5. Before this stabilize the two ends and use some machine to tension it to pull it. When this steel bar or this part of the concrete is break or the steel bar is broken, then the value you can get this strength, tensile strength. Actually, maybe when you do this test, you can imagine the failure mood at this part, the concrete crack or then broken, or in the middle the concrete is good. Because the tensile strength of the steel bar is too high than this concrete. So that means, of course, the steel bar cannot be break, only because the concrete break, the tensile strength. So actually, it's think of maybe we have a break and so the normal we should have 820 to 95, and 950 to 10, and the 1030 to 1150. But in the middle is kind of a half hour, so a little bit long. Maybe we can start at 10:20 and we finish at 12. So we see this tensor strength method. One is the face-to-face tension test method. Another is splitting test method. So for the face-to-face tension method, it's a little bit easier. Just bearing, the reinforcement and the pull and just pull it. When the computer break, you can go to the force, then it's the strength. For the slitting test the measurements like this. When the specimen splitting crack, then you can go to value. But this value, if you want to transfer it to this FT, it will be use this column. This FTS. S means the slitting test method, FT tensor size. So because here we got the actual tensor strength, we use FT. Now, first we need to calculate the FTS equal to F divided by pi A. A is the A is the area of this, the slitting surface. Once we got the FTS, FT and FTS got this relation 0.9%, 90% of this. So these two methods to getting the tensile strength of the concrete. So and also another characteristic is that the constraint of this, given the constraint condition, we will got given the strength value. So this is the cube, and the both side sigma 1, sigma 2. When the sigma 1, sigma 2 compression and compression is also in compression, then the concrete strength increase. That's like the cube. We put the concrete in the cube, steel cube. Then the strength, the concrete strength will increase. But when the sigma 1 and sigma 2 is in different, one is tension, one is compression, then the concrete strength will decrease. I think this is easy to understand. Okay? So if this sigma 2, you just tension and the sigma 1 is compression, and at this condition, you will find the test result will be decreased. But another situation is when sigma 1 and sigma 2 also both in tension, the value remains unchangeable, have a little influence. It's a little bit strange. But the result shows like that. If you have a chance, you can try. You can make a specimen and put on the machine to try if it's like this. And another concrete stress and compressive strength, normal stress and shear stress. So the normal stress is the stress. The direction is horizontal. Not horizontal, it's a, how to say, vertical, the direction is vertical to the surface. And the shear strength is parallel to the surface. So this is normal stress and the shear stress. When in the value the sigma reflect the normal stress. FC is the concrete strength, paper strength. It's smaller than 0.5 to 0.7. The concrete shear strength increase with the increase of the compression strength. So here is the increase gradually. Turn up, and then it's decreased. So that means the shear force and the compression, the normal stress, the shear stress and the normal stress, the relation. And at this range, the boost increase, shear stress increase with the normal stress. But after that point, nearly here, and the shear force, the shear stress will decrease with the increase with the normal stress. Nearly at least 0.6 FC. The shear force increase to the maximum value due to the development of the internal crack. The shear stress will decrease. So that's the reason why after this the shear stress decrease. Because when the normal stress is too high, maybe inside the concrete some small crack generated. Once the concrete generated some crack, then the shear stress will decrease quickly. Because the integrity of the concrete is not so good. So that's the reason why at least nearly 0.6 FC, the shear stress will decrease gradually because of the inside crack in the concrete. So concrete strength and the complex strength, triaxial compression. Triaxial compression actually is just we have talked before the concrete in the circular steel tube. And then evidence is then called this triaxial compression. So for this situation, the concrete strength is equal to FC, what's it called? Prime. So use this formula to calculate the stress where sigma 2 is the lateral compression stress, and FC prime is the cylinder compression stress. And this K prime we will also identify value on the book. But some value I think 50, 30 you can find on the book. Actually, need to take a table. So that's an example we have talked before. The triaxial compression using the arch bridge. Concrete steel tube. concrete field steel tube concrete, and the first concrete column with screw stirrup, screw stirrup. Actually, now it's widely used this, but while this the advantage of this increase the strength of the concrete. But what happened? I said everything actually at the same time not only the advantage, because they have disadvantage. For this structure, for this component, what's the disadvantage do you think will you have?
The concrete is inside.
Yeah, the concrete is put in the steel tube. What's the disadvantage?
If there is any information, we cannot arrange it.
Hmm?
We cannot arrange. If there is any problem, we have to remove everything.
Yeah, maybe there's some problem. Yeah, but
It's the brass option. And it's brass become heavy.
heavy,
Self weight.
same way.
It's high.
Yeah, but that's not the main disadvantage. Actually, that's way self weight can be one of the advantages because for this large span, you need to build this ring first.
Yeah.
If it is constructed by concrete, it's very heavy, it's very hard to build this large span ring. But if you use empty cube steel, this steel tube, it's not so heavy. Actually, it's quite easy to build this large span. So you use the empty tube, build the ring first, and then pour the concrete inside, make the stable structure. Actually, this one this weight of the concrete and also make it stable. So that actually this same weight can give the advantages. But the disadvantage actually for this concrete field steel tube, sometimes the inside the concrete cannot be filled so tight. Sometimes the concrete and the tube may be separated, not connected together so tight. So at this region, the force is different with the original design force. So sometimes
It should be the concrete and the steel should be in constant compress, so that it won't be if there is just air inside. If there is not so tight, at long it won't be strong enough.
yeah, if the steel tube and the concrete cannot cannot touch very tightly, so that means there may be empty inside. Yeah, it fills.
It's not
So many questions, many problems will come with the crossing and the loss of strength and maybe not stable. So this is good material, this is good structure, but sometimes it will happen. The quality, because when you pull the concrete inside, it's very hard to make sure all the tube is filled. Yeah. Because sometimes not only the tube, maybe they put some of this screw stirrups inside to increase the strength. You know, this screw stirrup inside, that makes the concrete is very hard to fill everywhere. maybe sometimes we got an empty inside or hole, or some hole inside, so it's not so it cannot reach very the ideal situation we think. We want to be feel the tube is filled totally by the concrete, but sometimes maybe here the hole is maybe not so good.
So actually, one of the disadvantages, can you say the calculations are not precise?
Okay, what?
Calculations are not precise because
Yeah.
you can feel the concrete in the steel and it can't feel like the whole.
But this maybe sometimes it will happen like this, but most time it's
Precise.
yeah. And also we see the steel and the concrete have the similarly the thermal expansion coefficients. But for this situation it's different because the steel tube is outside, the concrete is inside. And when the sun is shining, the steel is first is expansion, but the concrete inside maybe have not reached so many power. The steel is expansion, but the concrete is still there, so it's easy to separate it. Okay? So this is another case, triaxial comparison. Okay, here these three comparison concrete appear, concrete field steel tube concrete and the reinforced concrete column mostly in the column of the bridge or the pile, some structure like this. And then the second, we see the deformation of the concrete. The practice or the deformation properties of the concrete. And for the concrete, the deformation, they actually there's two types. One is induced by force, by load. Actually, another one is induced by the natural characteristics. So even there is no load, no force act on the structure, the deformation is still happening. So the deformation factor of the concrete included loading method, loading time, and temperature, humidity, text size, shape, and strength of concrete. So deformation includes deformation and short-term monotonic load, and deformation and long-term loading, repeated deformation and loadings. Wire deformation. This type of deformation is induced by the load. This type of deformation is just because of the natural characteristic of the concrete, the shrinkage or the creep, the temperature change. So the experimental condition of the concrete and the monotonous and short-term load are uniaxial compressed loading and equal spring ratio with and test spacing and the high elastic component attached to the spacing together under the condition. So this is the curve of the stress and spring and stress for the concrete. The concrete deformation performance and the monotonous and short-term load. We can see at the first part is the concrete works like the elastic material. This is this part is the stress increase with the strain and with just the proportional. But when it's reached here, constantly increase the strain, the deformation of the computer will increase greatly. So FC, here FC is the actual compression strength. And sigma, what can it be? Say, no.
Excellent.
How this number of it?
Excellent.
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 Excellent. Excellent.
It's not excellent.
No.
Excellent.
Excellent. No, excellent. No. Okay. Shape. Step along the okay. You find it? So here, this figure is not is the old one actually. In this new book, they will replace this. Is A, B, C, says express, and here C is the FC, E equal to 0.8 FC, here 0.3 FC, and this string, so here is a string, here is a stress, C0, cheek string, this residue stress at this point. So raise another E and E here. So the meaning, the point that A, B, C, D, E is the same. Oh, maybe just the symbol is different. There you use that symbol, here you use FC, in the new book you use FC. And the FC is the actual compression stress. So actual compression stress, do you remember how to get this value? Use what type of specimen to get this value? And I'm here.
Action. We take 2 1 F A area.
No. I mean, you use what type, the size of the test specimen. What's the specimen is like? What's the size of the specimen?
Is a circle.
Is circle or present?
Circle.
Circle?
The actual compressive strength.
No circle.
Oh.
Right. See?
Right. Oh.
Circle is this.
Yeah.
Circle is which one circle? See here. Circle is used in Europe or American or United States, Japan. They use this circle with a 6-inch diameter and a 7-inch height. So for the actual comparison, we use this measurement. So here on this figure, FC here actually is the actual compressive strength. So it's different with the C50 or C50, that means the cube. The strength use the cube, 15 cm cube. So this, I remember this symbol is Ipsilon.
Cube.
Next. Okay, now we just correct some. It's corresponding to the P spread is equal to 0.12, and then the result at the point that this point corresponding to the ultimate compressive strain equal to actually 0.13. This in China we use this value, the ultimate compressive strain. Actually, not only in China, other countries also use this value. So this is the complete deformation performance under monotonous and the short-term load. And the always part actually is work like the elastic material. And then gradually AB part is not exactly elastic, it's some of the plastic, it's not a straight line actually, it's just getting some of the curve. So here from the B to X, the curve is more how to say medium.
It's going to be little compact. It's going little compact. It's going to be little compact. Little hard.
What's it mean?
It's going to be not
Strong.
little strong. I don't know. Compact.
Compact.
Like little hard.
I mean, from A to X, the company is working like is an elastic material, not just it's not like the elastic material. Actually, elastic material means the stress and strain change how the fix the proportional relation. But if the material is plastic, the ratio between the stress and strain actually is changed. It's not fixed. So the stress and strain, or how to say just like the load and the deformation, you build this structure maybe 10 Newton, and you got a 1 millimeter deformation, and you got a 100 load, 100 Newton, and then you got a 10 millimeters. Just the relation is just fixed. That's the elastic material. But the relation is gradually changed. It's not a straight line. doesn't work. It works like the plastics. So the relation between the stress and strain actually is changing. Not a straight line. It's a whether the relation, the ratio is changing. So the concrete loading process actually is divided into these three phases. OA stage is the elastic phase. So AB stage is plastic stage. So crack stabilization phase. So at that stage, the crack is appear during the in the concrete. The BC phase, that's the one phase of the cracking. That means BC, actually C, breathe faster or breathe. So this BC phase, unstable phase of cracking. So this curve, O is the elastic stage. AB actually is the plastic stage, and the BC is the unstable phase. So main factor that impact actual compression stress and strain curves for the concrete include basically different grade of the concrete have different this curve. So this 40, FC 40, and this going to this means C50, C40, C30, the different degree of the concrete. Then the curve of the stress and strain is different. We see this picture, especially the decreased part. For this going up, this part is similar. The change is a little bit different. But for this decreased part, it's changed a lot. So manufacturing that they impact the actual compression stress strain curve of the concrete. You can see from this figure. When should we have agree? 22 is 1020 to 20 to 11.5 or when should we have agree?
Yeah.
Normally now,
Okay.
because we get 5 or 10. It was 10, we get to
So with low grade concrete is even compression, the ductility is better than high grade concrete. So that means here when the concrete grade is lower, this part will become more horizontal. But when the concrete strength is higher, this decreased part will become a very sharp decrease. So that is the ductility is better than the high grade concrete. The middle, this one,
which one?
as I want this name to
Ductility.
check.
Ductility.
You mean that we can easily.
Yeah, and easily deformation, yes. The strain rate is small and the peak stress decreased when this increase curve slope descent significantly slow. This one. So another factor actually that impact the actual compression stress, the lateral confinement and the testing technology and the condition. Actually, that's so our textbooks have introduced some of this, but it's not much. Just a small test. You just have a reading. It's not much things. Just because of the test technology, it's a little bit complicated to explain. Have you ever do some such of the compression test of the concrete or something other material? I'm not sure if we can at the annual test we can arrange some of the experimental class. We do we make some of the specimen and to put on the machine to do the test to measure the strength of the concrete.
Okay.
I think it's very much.
So maybe still have 5 minutes, right? Because we start at 10:20, every class we should have 45 minutes.
Yeah.
Sorry. Right. No, that's very important to the home. No, that's the Jean is close. It's not 15 minutes. 20 minutes.
So we continue to see a little bit more content. So now we see the modulus, the company less modulus and the deformation modulus, because the modulus E is very important when we design. E, because E multiply I represent the strength of the structure. So how to measure or how to get the value of E of this material, concrete or steel or other material, that's very important. So E, the modulus of the concrete, elastic modulus. So given the method, you can give the value. So in your test, we introduce the 3 different types of the modulus. The first one is the original elastic modulus. This one is just from the original point. So this curve, actually E between the stress and the strain, where is E? Stress is what? Stress equal to strain multiply E. Is that? So once we got this curve of the stress and strain, actually we can got E equal to stress divided by strain. So from this curve, that means, but we use which value? if you use this from the original point or from another point from this tangent, so different method you can get different value.
You can choose any of them.
Depends on which situation you use. Sometimes say in the both textbook, the first value they reduce the original elastic module. They got this tangent from the original point. So namely the origin elastic modulus is the slope of the tangent of this alpha. So this is the tangent of this point. Another is the tangent modulus. The slope of tangent corresponding to the tangent modulus, just something like this. At the one point, on the curve, at the point of the curve, you do the tangent. You got this value. We use this value as the modulus. And still got another one. Is the deformation modulus. Deformation modulus, because this point, between this point, because the connected with the original, then you can got this tangent. Or if you did at this point, you do this tangent, you can also go to this another modulus, the second type, this tangent modulus. If you draw the straight line from this point to the original point, you got this straight line and you get the tangent value, then this is another method, deformation modulus. Because this point, this is the force, this is deformation actually. So this tangent reflects the deformation modulus. So different method and different value. And then another modulus is the shear modulus. Shear modulus can calculated by the normal modulus EC. Shear modulus use this symbol G, GC, and the normal modulus we use this EC. And by this formula, we can got the shear modulus. And this word, how to pronounce this? This mu. The Poisson coefficient, Poisson, how to pronounce it? In Chinese it's Poisson B. I think in Poisson, I find this word very complicated usually. Poisson ratio. Remember?
Ratio.
Poisson. Poisson ratio. Actually, I think this usually already studied in the material mechanics. Poisson ratio. Poisson ratio. This coefficient reflects the deformation between the vertical and the shade. The shade deformation two directions. This direction and this direction actually. Yeah. The deformation relation between this direction and this direction.
The GC is the
GC. No, GC is the shear modulus. Because suppose you see a column, if you push this direction, the deformation is in this direction, this column will be getting shorter. The dimension will change. But at the same time, this direction also increase.
Yeah, yeah.
So the relationship between the deformation of this direction and this direction actually you causing issues.
Right.
So we have a break. Maybe 10 minutes break.
Now she can continue.
Continue.
Yeah.
We can continue, but when we finish,
Need water. I need the water. I have.
doesn't matter.
Now she. We have to do quick. A lot of PPT. We have to finish it.
It doesn't matter, we have enough time.
Yes.
We have 80 classes altogether.
Now there is a lot of experience. We want to do experience.
Okay.
We want to do practice.
Practice.
Yeah, we want to do more practice. We have to study.
This is the practice video. This means.
Different method, they got different values. And use which one maybe depend on different situation. And then for the Chinese code, we produced this formula to calculating the elastic modulus. Looks a little bit complicated, but it's really simple. Only use this FCUK.
Now, how to say this is FCU and portion? Portion. This is full meaning CU. What's the meaning?
This one,
Yeah, portion.
the cubic compressive strength. I think we have introduced it before here. Here. Actually, it's a cubic compressive strength. Standard value of the cubic compressive stress. So once you know the cubic compressive stress, you can use this formula to get the elastic modulus. This formula is produced by the Chinese code. And this formula is actually fitted by lots of experimental data. And but this maybe if you're not in China, if you in your country the soil, the sand, the water is different. Maybe this formula is not so correct because all this is based on because the strength of the component is influenced by the material they use, the sand, the water, the soil, cement. In China, or maybe this material is different with the material in your country. But maybe the difference is not so large. You can just make a reference. I think this course of PC, yeah, on the textbook we got this formula. You can find this in the textbook. So that means when we calculate, do the design, we can use this formula to get the elastic modulus of the concrete.
Normal modulus.
Yeah. Once you got this FCUK, then you can use this elastic modulus. So actually, it's easy to use. you go back to your country, maybe it will be different. So, in order to do the nonlinear analysis of the concrete structure, the nonlinear stress-strain relation is used. So, different models are introduced like this. The concrete stress-strain curve. As shown in this figure, a wide range of description of improvement growth in China or other countries use this curve to describe this stress and strain of concrete uniaxial compressed stress strain curve. This was divided into two parts. The first part is the rising section, the second is the descending segment. So for this rising section, the stress and the strain of this relation. See, compared with this figure, actually, you see, this is a real curve got by the experiment. But this one is the curve in some of the code. They made for the simplified, it's easy to use. They simply divided into two parts, rising part and descending part. So for this part, they give the formula, this part of the formula. The real situation actually is like this, go down this curve. But now they just use the simple relation to represent it. See here the concrete peak strain is 002 and the ultimate compressive strain 0038. A little bit difference. In China we use 003, normal we use this. So another curve, as shown in this figure, the model based on Chinese code is relatively simple. This one is even simple. The second section is quadratic parabola.
Yeah.
So this one parabola, and then the descending decrease. The second is a horizontal straight line. They just let's consider the descending part. Just use the horizontal line. Yeah. So that's make it more simple. More simple means actually is not so precise. The precise. It's not so good. It's easy to use, but at the same time you have missed some precise. But for the real project, it's enough. We no need to be so precise to be. Actually, this section is enough. After this, it's not so important.
The descending part. You can ignore the descending part.
I think you just pick into this part. Because after this point, actually the crack already got lots of cracking. So got this formula. If you have interesting, if you do some research, after you gradually do some graduate study or postdoctor, maybe your research project you can contribute here. Okay. For the real project, actually this part is not so meaningful. And the creep deformation of the concrete and the long-term load. So creep. So what's the meaning of creep? Yeah, the creep deformation. So this force, the concrete beam, if you or the bridge, you finish the construction, even if you don't use it, you may no time, no person, no other force. That means the force, the load is considered as no no change. Say the creep deformation is the situation, the load condition doesn't change, keep constant, but the deformation keep developing. So the deformation increase is not induced by the increase of the load. So the total load condition doesn't change, but the deformation gradually increase.
So, shall I say that the deformation is not caused by the load?
Yeah, it's mainly not increased by load. It's actually increased by the natural characteristics of the concrete, because the water inside may be lost, or some of the movement for the small part inside, small particle. So deformation of the concrete will increase with the time. Here, the important part, most important effect is time. Increase with the time and the long-term load. In case of the constant stress means the load doesn't change. The load keeps the constant, unchanged. And the strength of the concrete continue to increase with time. This phenomenon is known as creep. So this the reason of creep. So here give the reason. Creep actually is a long-term effect of the loading. It's long-term, but not because of the changing of loading. The water gel is gradually pressed out. The water actually inside the concrete was pressed out. The water loss actually, and the cement occurs gradually viscous flow. But this cannot find by your eyes. Actually, it's also yes. It cannot find by. Maybe you use the
Microscope.
yes. So the macro crack generally close, and the internal crystal gradually slide. Micro crack begins to change the temperature result of the various factor. Viscous flow of the gel lasts a long time, and the continuous generation of the internal crack and development. So that's meaning by induced by the internal change, the small crack or the water gel inside. So this is creep. As the situation, there's no change of the load, and the development with time. That's the creep of the concrete. The concrete creep influence structure mechanical behavior and mainly reflect as increase in the deformation and the redistribution of the second stress for the magnetic structure. So the second stress will because of the deformation is changing, the stress will redistribution. The producing redundant for the intermediate structure. What's this mean? Redundant. Okay, redundant because certainly ultra pretty because I think maybe you how you if you explain this meaning how to say not if you not use this word how to explain this meaning is redundant.
Producing redundant for example, like some when we have
is waiting.
All the okay. There's
Upon the water.
small
Small.
deformation.
Yeah. Something like this. And for pre-stressed concrete structure, pre-stressed loads. Yeah, here we can find some of the effect that influence the loads, the stress. Here, creep will influence lead to the loss to the pre-stress. Because of the deformation, generally, when at the beginning you press the structure with the side like this, but gradually the side of the concrete getting shorter, then the press, of course, the pre-stress will be lost. The steel bar was anchored not so tight, then the pre-stress will just dismiss.
It will lose its anchor.
Hmm?
It will lose its anchor.
Yes. Another well deformation, the shrinkage. Shrinkage is different with the creep, but also induce the deformation of the concrete. This is the concrete no-load deformation. So the creep is under the situation with the no change, but this shrinkage is totally no load deformation, totally induced by the characteristic of the concrete. So in the concrete seeking and hiding for the physical and chemical process in the value decrease over time is called shrinkage. Shrinkage of concrete includes the following two main reasons. First one is the initial hardening cement produced in the solidification process, the value change. Chemical shrinkage is value shrinkage. Because the process of the hardening actually is the process of the chemical change. And the next one is the lateral shrinkage in concrete, which is mainly caused by the free water reproducing and loss of water. So why during the pure process we need to put water on the cover or on the surface of the concrete to supply the water for the concrete, because during the hardening the water will lost. So we need to provide supply the water to the concrete to make a good foundation for the hardening.
Sure. I have a question. During the construction, the Chinese construction of the building, around the area, they put the wall, and there is water. See, when the Chinese construct the building, any building, they put a wall to protect. So there is some water.
Yeah.
Yeah, why there is water? I see, like
It's out like that.
yeah, and then there is water.
Something, the water is like.
Water is split. No,
No, the water on the concrete you mean outside?
yeah,
Outside.
Really?
yeah, in the edge, yeah, they put some tube.
It's small
Small tube.
Yeah.
You mean the surface, but there's no water in the tube.
No, the water. Is
Water.
yeah.
Also need connect the materials.
But
Yeah.
where is it, put the water?
If they don't keep the water, the walls will be
Drawing off.
not good in future. It's against good joint materials.
When the build,
It's not inside,
when the build
then out.
once the building
Then out.
the place and everything,
They put some water.
you're wrong. The build is wood to protect. Yeah, the water, they are working there. They are working there. With building the,
And the community,
yeah, the roads here.
yeah.
Maybe in the road, the car is passing.
You don't know
The road here, they put some water. The water like in the boat like this. And the water.
even is there that you
Like if you, this is the, if you're outside,
Yeah.
if somebody is
don't see
here
that.
Yeah.
and is passing, people are passing, they will see here that there is water. Yeah, there's plenty of water around the world.
Really?
You have not received it.
I think that they mostly maybe to make the how say the weekend that's the material in the area that's the make those things here.
Because when people are, they put firstly the protection to protect so that people will not see what they do inside. You know those things, right?
Like if they are just like their construction site, they build a fence.
Yeah, that's
And when you are passing by, like you feel some water
Yeah.
shower. Actually, it's trying to say that, see, one, like maybe, let's say this building, for instance, if they are building it, they will build a fence around it.
Yes.
And if you are walking around, sometimes you feel some water like falling onto you. They want you to see what-
Understand. So I think the main reason maybe they just make the as material clear. Because we do the building, there will be also the dust in the air. If you put some of the water, you can just
And I said that.
yeah. I think that this main reason. So this is the second deformation of the concrete of the shrinkage. That's mainly used by the chemical and the physical. That's the chemical shrinkage. The physical shrinkage is two reasons. And the main effects of shrinkage are the composition and the ratio of the concrete. Because given the concrete, if the ratio of the water is large, that means the shrinkage of the concrete will be large. So different ratio between the water, sand, stone, you have different ratio for different grade of the concrete. So if the ratio of the concrete, our large water, a large amount of water, then the shrinkage may be yeah. So the current conditions use the environmental temperature, the humidity, and all impact the effect to keep moisture in the concrete of the membrane. And the body surface ratio, yes, the body surface ratio. Sometimes for this case, is in some of the large abutment or some of the large, the anchor of the suspension bridge, they will not aware of the concrete. For this type of situation, most serious problem is the effect of the temperature inside. Because the large volume of the concrete inside, during the hardening, the chemical reaction, they generate a large amount of hot energy. It will be very hot. And this effect, the concrete will be easy to crack. So for this situation, you will see some of the they will also hole on the larger value concrete. They draw some hole, put some the tube inside. On the tube, in the tube, they actually the cool water inside goes through to transfer the energy out to reduce the temperature. If the outside the temperature is low, inside the temperature is high, the concrete will easily destroy and crack. So for this situation, and also we will influence the shrinkage of the concrete. And the shrinkage of the concrete impact on the structure mainly as membrane crack before loaded. Before putting it into use, maybe have no load outside on the structure of the component. It's already cracked by itself. And the pre-stress loss also induce pre-stress loss. And secondly, internal force is produced for in the yes, same as the crate. So because the stress in structure not only can be induced by the load, outside load, also can be induced by the deformation of the structure. So the deformation can be induced by the outside load, or also can be induced by the crack, the creep, something inside the deformation actually. So this can the influence of the shrinkage on the structure. Remember the crack, stress loss, and the second internal force. So till now, the content about the concrete, we can just finish. The next part is about the steel reinforcement. Just to see this figure, maybe have another over clear for the when we do the experiment to measure the concrete strength. On this test, we got this two figure. So this is the cube specimen. Because on your book, you got this